Welcome to the Clark Planetarium and our Science on the Sphere. My name is Tracy, and with me today is Nathan. We live on an amazing planet, often called the Blue Marble Planet. We can look at our Earth from space and see water, beautiful blue liquid water. Water is constantly moving and shifting in processes. We have lakes, rivers, underground aquifers, clouds, ice, and let's not forget our oceans. Have you ever wondered what our Earth would look like without water? Not only would all of the blue disappear, but there would be no white clouds or green plants.
All life that we know of needs water to survive, and without water, our Earth would be a lifeless desert.
Fortunately, for most of us, water is pretty easy to find. When we need water, we can turn on our faucets or go to the store and buy a water bottle. But not all of the water on Earth is drinkable.
Do you think you could go to the beach and drink a big glass of ocean water?
Only 2.5% of all of the water on Earth is fresh water, and a lot of that is ice. But just because we can't drink the oceans doesn't mean they aren't important to Earth. The oceans are filled with life, ecosystems that we depend on. And the ocean is responsible for 40% of the heat transportation, affecting weather and climate all over the Earth. So what's keeping all of this water moving? If you fill the pan with water and set it on your table, after a while, the water would settle down and stop moving. But the water covering 70% of our Earth's surface is constantly moving. Let's take a closer look at some of the processes that keep our oceans in constant motion.
Energy from the sun is a huge factor in the motion of air and water on the Earth. Energy from the sun warms our Earth and our atmosphere. Hot air rises and cool air sinks, causing movement. When air consistently moves in the same direction, we call this a current. Here, we have a model of wind moving around the Earth. Red represents high energy winds. Can you see any patterns or currents in the air movement on the sphere? Like our atmosphere, the ocean is also moving, but it's a little harder to see. We can see the surface currents here on the sphere.
Two things that can affect surface currents are temperature differences and wind. That's right, the friction of wind blowing along the surface of the water can create movement. If you've ever been near a lake when the wind starts to blow, you can watch as the wind pushes the water. It's pretty amazing. And that can happen on a much larger scale out in the ocean. You can see where the oceans are warmer along the equator. The red being a warmer temperature. This is where Earth gets more direct sunlight. You can see the cooler temperatures around the poles, where the sunlight is more indirect. So you get the same effect as with the atmosphere. Warm water rises, cooler water sinks. Let's think about that for a minute. Warm water rises, but how high can it rise? Only to the top of the water before it evaporates. Air will continue to rise until it cools off. But the closer water gets to the surface, the more exposure it gets to the energy of the sun. So warm water is going to rise and stay close to the surface. Do you remember the pan of water we set on the table? Imagine we take that same pan of water and set it on the stove, heating the water from the bottom. Ask an adult for help if you want to try it. We start to see movement as water rises from the bottom of the pan, but sun warms the ocean from the top, creating movement and currents along the surface. But there are miles of ocean beneath the surface that doesn't get as much energy from the sun.
Do you think this means there is no movement in the lower levels of the ocean? The deep ocean has a system called conveyor belts that move water around the globe. If you've ever seen Finding Nemo, Marlin rides one of these conveyor belts with the sea turtles. These moving currents are caused by changes in temperature and the differences in salinity in the ocean. Just like temperature changes the density of air and water, the amount of salt can make water more or less dense, making it rise or sink. It's mind-blowing how many things are affecting the movement of our oceans. We don't have time to talk about all of these factors today, but I wanted to help you start thinking about a few other factors in ocean movement.
First, is the ocean floor smooth? You can see on the sphere high mountains and deep trenches. What happens to a river that goes through a tight canyon? It speeds up, turning into rapids, right? So what do you think happens to the ocean when it travels through a deep sea trench? There's a link to a YouTube video below if you want to know more about that. And finally, is the sun the only source of heat on the Earth? Can you think of anything that might heat up the ocean from beneath? Like our pot of water on the stove? Another source of heat comes from inside the Earth itself, the layer of hot liquid rock under the crust, called our mantle. Places where this heat escapes through cracks in the Earth's crust are called vents. There are deep ocean vents heating our ocean from underneath. That's pretty cool. These cracks are in Earth's oceanic crust and mostly happen where tectonic plates are pulling apart.
Earthquakes are likely to occur wherever tectonic plates are in motion relative to each other. When earthquakes happen near or under the water, they can sometimes cause tsunamis. You can see on the sphere how an earthquake in the Indian Ocean created tsunamis that travel around the entire world. The ocean is an incredible system of movement and ecosystems, so even though we can't drink ocean water, it does help create a world where life flourishes. Thanks for joining us at the Clark Planetarium. Keep learning even though it's summer, and remember to keep looking up.